Madam, please begin.
Okay.
Lima madam, can we start? Just inform me so we can start.
I think we are live now. Jiten sir?
Yes, please. Please begin.
So a very warm good morning to one and all present over here in webinar. On behalf of Parul Institute of Pharmacy, Parul University, I Pooja Bhavsar welcome you all in today's webinar, the topic of basics of ALSI method development. So before starting with this, I would like to introduce our today's eminent speaker, Dr. Dimal Shah sir. So, sir is presently working as a professor at Indukaka Itkowala College of Pharmacy, New Vallabh Vidyanagar. He has a very rich professional experience of 18.5 years. Sir is also recognized as a PG guide and PhD guide from Gujarat Technological University as well as CPM University. Sir has guided total 28 students for PG and 2 students are pursuing PhD under his guidance. Sir has even organized QIP FDP. Sir has organized total 5 courses, seminars for the FDP. Sir has even handled the industrial projects. A four number of projects has been handled by him. And even he has published more than 83 papers. It is a huge number. And 7 books has been published. Sir is even has delivered the lecture in a 12 conferences. He is invited as a judge and resource person at many technical events. Even in this whole list, he has received a Best Researcher Award at 5th Indo-Malaysian Conference organized by Association of Pharmacy Professionals at Babaria Institute of Pharmacy on 27 Feb 2019. Even he has received a certificate of merit for Dr. P.D. Sethi Annual Award 2015 for the paper Development of HPTLC Method for the Estimation of Ondansetron and Ranitidine in Combined Dosage Form. Even he has again got a certificate with the same Dr. P.D. Sethi Memorial Award for the paper HPTLC Method for the Estimation of Anti-Diabetic Drug Teneligliptin. Even sir has received third prize in AICT MHRD organized COVID-19 Mega Challenge for fighting against Corona. In that particular competition, the total 2,700 projects has been enrolled, and from the huge 2,700 number of projects, sir has awarded the third best research project. So now I think that this introduction is more enough to introduce the speaker. So we have a great opportunity to listen, sir. So I invite sir to proceed for this. Over to you, sir.
Thank you so much, madam, for nice introduction, and thank you to Parul University and specifically Pharmacy College for inviting me to share my views on the topic LC method development. Special thanks to Falguni madam and Lima madam for giving me this opportunity to share my thoughts with the students. I hope final year students and MPharm students are a part of this event. So I had kept my topic in such a way that in future they'll have some basic idea about the LC method development. Fine. Now, why LC method development specifically? So chromatography is basically a technique which can be used for quantitation and quantitative analysis, and widely used technique in industry. I hope someone's mic is on. Kind request to participant to please mute the mic so that I can. Hello. Kind request to the participant.
आपले असतील आता सगळे लिमाच दिसायलेत. लिमा 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 सगळे लिमा आहे ना. काही
Hello.
जमजम लिमा का बरं एवढे काय माहिती सगळ्यांनी लिमा
Yes, sir. I'm changing their role. I'm changing their role. I
Okay,
request
okay.
all the participants to join through PU webinar.
दिसलीच सकाळी.
Fine. So, what is the purpose of selecting LC? And why LC specific?
कमेंट सेक्शनला अटेंडन्स टाकायचे.
हा टाकायचे.
फेसबुकला आता काहीच नाही तर कोणीच ते टाकत नाही. काय माहिती कितीदा बसून करता येईल काय करता
Just a second, sir. We are just moving the attendees. It will take a while. Just a second.
अटेंडन्स चेक करता
हा टाकायचे.
काहीच नाही.
I request all the students to join through PU webinar. I request all the students to join through PU webinar. I think you can proceed now, sir.
Okay.
Lima,
Thank
sir.
you. Thank you, ma'am. Yes. So basically, liquid chromatography is a specific technique which can be used for separation and quantification of a compound. Basically, chromatography is a separation technique, but when it is clubbed with detector or detecting responses, it can be used for quantification as well as separation of the compound. So all the pharmacopoeias are now using chromatographic method for the quantification of the single compound or mixtures of compound. Now, the topic that has been given to me is basics of LC method development. What care, what precautions that we need to take when we are developing a liquid chromatographic method, HPLC method. The same principle may be applicable to HPTLC also. So, because the basics remain same. So, I have tried to discuss about the HPLC method development and the various steps that are involved in HPLC method development, and the care that we need to take is, or the point is that we need to remember is, we should be aware about the chemical structure of a compound. If you want to develop a HPLC method, it is necessary to know the structure of a compound, which compound we are going to analyze and separate. The pre-treatment that we need to carry out, selection of the mobile phase, which mobile phase has to be taken, same way with stationary phase has to be taken, and the kind of detectors that we have, validation aspect and application of these methods for the analysis of the dosage form. So let's take the first part. When we are developing a liquid chromatographic method, what we should know before starting a method development. We should be aware about the chemical structure of a compound. Why? Because it provides the best clue for the selection of initial HPLC conditions. Suppose you want to separate a chiral compound or isomers, you have to go with a chiral chromatography. If you want to separate ionic compound, you have to go with an ion exchange chromatography. If you want to separate biomolecules, in that condition, we need to go with a gel chromatography or gel permeation chromatography. Fine. So the nature of molecule is very much important, and we need to study that aspect. Second thing that we should know about the compound is the molecular weight. What is the molecular weight of a compound that we are going to separate? If it is a low molecular weight, you can go with a normal phase or reverse phase chromatography. If you are going to separate large molecular weight compound like polymers, macromolecules, biomolecules, in that condition, we need to go with a size exclusion chromatography. I hope you all are aware about the separation principles that we have. Okay, there are basically 6 separation principles on the basis of which the separation of compound occurs. 1, adsorption chromatography, partition chromatography, ion exchange chromatography, size exclusion chromatography, ion exchange chromatography, affinity chromatography. Fine. So these are all separation principles which are used in chromatography for the separation of the compound. So before selecting a chromatographic method, we should be aware about the size of the compound. The next thing that we should be aware about the molecule is the polarity of a molecule. If your molecule is polar, you can go with a reverse phase chromatography. If your molecule is non-polar, you should go with a normal phase chromatography. Now the question comes, what is a reverse phase chromatography? When a stationary phase is non-polar and your mobile phase is polar, that chromatography is called as reverse phase chromatography. And in case of normal phase chromatography, your stationary phase is polar and your mobile phase is non-polar. So that is called as a normal phase chromatography. So depending on the type of the molecule, the nature of the molecule, we need to select a chromatographic method. So these are the basic thing about the compound that we should know: its structure, its molecular weight, its polarity, then ionization constant. What is the pK value of my compound, which I am going to separate through chromatography? Okay, because based on that, I can select the mobile phase pH. If I want to keep my compound in unionized form, I should select pH in such a way that my compound remains in unionized form, and vice versa. A well-known equation which all of us have studied in first year of B.Pharm, Henderson-Hasselbalch equation, pH is equal to pK plus log salt upon acid. So this is the basic equation that can be used to find out whether your compound will remain in ionized form or unionized form. For example, the pK of your compound is 5. And if I keep pH 2 units lower than its pK value, that is, for example, if I am keeping 3, in that condition, my 99 molecules out of 100 or 99% of the molecules will be in an unionized form. Similarly, if the pK is 5 and if I keep pH 2 unit more, that is 7, 99% of the molecule will be in an ionized form. Fine. So this Henderson-Hasselbalch equation helps me to find out this Henderson-Hasselbalch equation helps me to find out what will be the pH of the mobile phase that I am going to use in chromatography. Okay, so the selection of the mobile phase is very much important parameter in the separation of a compound. Fine. So the another parameter that we should be aware about the molecule is the ionization constant. The next parameter we should be aware about the molecule is the log P value. Normally we call log P value as the partition coefficient. It's a partition coefficient between non-polar and polar phase, that is octanol and water. Ideally, log P value indicates whether the molecule is hydrophilic or hydrophobic. Okay, so if my log P value is more than 1, which means that my compound has hydrophobic characteristic. And if log P value is less than 1, then my compound is water soluble and it is hydrophilic in nature. Okay, so log P is also another important parameter for a molecule to be known. Next thing, we should be aware about the solubility of the compound, because solubility will help us to find out the mobile phase that we are going to select. Okay, it may be methanol, it may be acetonitrile, it may be any other thing. But we should be aware about the solubility of a compound, whether the compound is soluble or not. If compound is insoluble and if you are selecting such a solvent, then it may lead to precipitation of a compound in column. So we should be aware, we should be careful about the selection of a solvent for the compound. Fine. So if you look at the first thing, the basic characteristic of a compound that we need for liquid chromatographic method development is we should be aware about the structure, we should be aware about the molecular weight, we should be aware about the polarity of a compound, ionization constant, log P, and solubility of a molecule. Now, the second thing is we know the molecule that we want to separate or analyze, or we have a matrix in which that compound is present. For example, a tablet is there, paracetamol tablet is there, and we want to analyze the paracetamol. Now, this sample needs certain pre-treatment. There are certain reasons why we should carry out pre-treatment of the sample. One thing, we want to avoid matrix effect. For example, we want to remove matrix material, okay, like excipients or some co-eluting compound. We need to remove these co-eluting compound or excipients before we perform analysis. Otherwise, they will interfere in my analysis. Okay. Detectability. It may happen that my compound has a low detector response. If I carry out HPLC analysis of a compound, and if my compound has a low detector response, I need to have certain methodology. I need to carry out certain derivatization of a compound so that its response can be improved. Third important thing why we should carry out pre-treatment is we want to stabilize an unstable analyte. My compound is unstable. By some chemical reaction or by some chemical transformation, I am converting this compound into a stable molecule. Okay, so these are some objectives why we are performing pre-treatment of a compound. The first thing is detectability. And to improve detectability of a compound, suppose, let's take an example of a compound which do not have a chromophoric group. I hope you are aware about the chromophore, a group which is responsible for the absorption in UV light. Okay, that is called as chromophoric group. Suppose a paracetamol is there, then there is a chromophoric group which is responsible for the absorption of the light. Fine, but there are certain compound in which this chromophoric group is absent. So in such condition, I have a UV detector. I don't have any other detector with me. So I need, and I want to analyze this compound. In such condition, I have to perform derivatization of my molecule. By chemical reaction, I'll attach some additional group that will work as a chromophoric group for my compound. Okay, so this derivatization can be carried out pre-column or a post-column. Like before you introduce your sample, you carry out the chemical derivatization, or once your compound get eluted, you carry out the post-column derivatization. So these are various derivatizing reagents that can be used for different functional groups. If carboxylic acid is present, you can go with this compound. If alcohol and phenols are present, you can go with dinitrobenzyl chloride. If aldehyde is present, then you can go with this compound. So like for different functional groups, you can go with a different derivatizing reagent to improve the detectability of the compound. Now, whatever the derivatizing reagent that we are using, it must comply with certain characteristics. Must be stable, should be non-toxic. The reaction must be stoichiometric. It must react with compound readily, and it must not interfere with the detection of the compound. Now, it may happen that when you are using a derivatizing reagent itself is giving a peak, or it is co-eluting with your compound. Co-eluting means it is giving the retention time, it is giving the peak at the retention time at the same time of your compound. Fine. So we have to be careful while selecting a derivatizing reagent, and the reaction between derivatizing reagent and your compound must be stoichiometric. Okay. The another important reason for pre-treatment is minimize matrix effect. As I said, if your sample, if your compound is a sample mixture, and if you want to analyze one or two compounds out of this mixture, we need to eliminate the effect of other compounds. Okay. Suppose your sample is a plasma, or if you are analyzing saliva samples, or if there are more than one compound which are present and which are interfering in your analysis. So in such condition, we have to minimize the effect of unwanted compound. It may be done in a different way. You may carry out solvent-solvent extraction, where a particular compound which is to be analyzed will come into the required phase, and the unwanted compounds are getting eliminated. Second thing that you can do is you can carry out the protein precipitation. Okay, where plasma proteins will get precipitated out and they can be eliminated from the analysis. Otherwise, plasma protein will get precipitated inside the column and it will clog your column. So it is necessary to remove plasma component when you are performing analysis of blood or plasma samples. Okay, because we want to analyze drug, not the plasma component. And second thing, these plasma component may interfere in your analysis. It may give you baseline noise. It may happen that these compounds may get precipitated inside the column. So plasma samples needs pre-treatment, and protein precipitation is one of the methods by which you can remove this interference. Third thing that you can do is particulate impurities can be removed by centrifugation, decantation, and filtration. Okay, so these are the ways by which you can minimize the matrix effect in a sample. Now, the things that you have decided is your sample characteristic, then your plasma sample, the pre-treatment that you need to carry out. Now, by knowing this much thing, you can start with the selection of HPLC method and initial conditions. If your sample is regular, like if it is a synthetic compound, neutral molecule, and if it dissolves in a solvent, then RP-HPLC, reverse phase chromatography, is the preferred choice. And for ionic, ion pair chromatography, ion exchange. Just a minute. Just a minute. Yes. So we have, if it is a neutral molecule, in that condition, we need to dissolve a sample. If your sample is soluble, in that condition, RP-HPLC method is the preferred method which we can use. And if your sample is ionic in nature, okay, where you can go with an ion pair chromatography or ion exchange chromatography, that is the preferred method. So, like the separation principles you can decide based on this nature of the sample. Fine. If your molecule is a spatial molecule, like a biomolecule, then you can go with a size exclusion chromatography. And if it is a polymer, again, you can go with a size exclusion chromatography. If it is a chiral molecule, having chiral centers, and you want to separate isomers, stereoisomers, in that condition, you can go with a chiral chromatography. So your separation principles will be defined and decided based on the basic criteria that you have decided. Okay. Now, the next thing that we have to do is we have to select the mobile phase that will be used in this chromatography. First is, what are the points that we need to remember while selecting the mobile phase? One is viscosity. Viscosity is an important parameter because the solvent that we are selecting as a mobile phase are pumped with the help of a pump at 2000 to 3000 psi pressure. So if the viscosity of the solvent is more, in that condition, more pressure has to be applied, and that will make your system unstable. So normally low viscosity solvents are preferred. Okay. Second thing, what will be the wavelength of analysis that you are using? Based on that, you have to select a solvent. Okay. Every solvent has a UV cutoff value. UV cutoff means a wavelength below which the solvent will absorb more than 1 unit in 1 centimeter cell. So ideally, we should not select a solvent where we are performing analysis below its UV cutoff value. For example, if we are selecting methanol as a solvent for the analysis of a compound at 210 or 205 nanometer, methanol should be avoided because methanol has a UV cutoff value of around 205. Fine. So that care has to be taken. What is the wavelength of analysis based on which we have to select a solvent considering its UV cutoff value? Compressibility. Now, solvent with high compressibility shows greater pulsation during pumping. As I said, we are pumping a mobile phase. And if your solvent is compressible, then it will create pulsation. And that is why a care has to be taken. Third thing, polarity of a solvent. Polarity of a solvent is also very much important parameter because that helps in the separation of the sample mixture from the stationary phase. Ultimately, the basic principle of chromatography is that your compound is getting distributed between stationary phase and mobile phase depending on its affinity. Okay, so in such condition, it is necessary to know the vapor pressure and polarity of a molecule, of a mobile phase. Okay. Depending on the polarity of a molecule, you can select the mobile phase. Fine. Second thing is about the vapor pressure. There are certain solvents which are volatile at room temperature. So during mixing, it may happen that some amount of solvent gets evaporated and the composition of the mobile phase will change. You are performing analysis throughout the day, and if the temperature rises in such condition, if the compound has a low vapor pressure, in that condition, the compound will get evaporated and solvent will get evaporated and the composition of the mobile phase will vary. So the another parameter for a mobile phase that we need to consider, for a solvent that we need to consider, is the polarity as well as vapor pressure. The most important parameter for a mobile phase is compatibility. See, mobile phase is usually made up of more than one solvent. 1 or 2 solvents or 3 solvents are mixed together, and that is used as a mobile phase because we want to carry out the separation of the compound. Now, are these solvents compatible with each other or not? For example, if you are using a buffer and an organic solvent or acetonitrile, it may happen that a buffer which is prepared in a water will get precipitated. Many a times we are using a gradient system where every solvent is filled in a different bottle, and this required quantity of solvents are mixed inside the mobile phase chamber and then they are pumped. Now, if they are incompatible, then what will happen? there will be precipitation of a compound. There will be precipitation of a buffer, and it may happen that it may create air bubbles also. Like when we mix methanol and water, we have observed that the temperature will rise because it's an exothermic reaction, and at the same time, air bubbles will also be created. So it is necessary to sonicate mobile phase, or you should have an inbuilt sonication facility that removes these air bubbles. But before that, we need to check the compatibility between each solvent that we are using as a mobile phase to avoid the problem of precipitation. Now, this point already we have discussed. If we are going from the separation of polar compound, we normally go with a reverse phase chromatography. Okay, and in reverse phase chromatography, the stationary phase is non-polar, so obviously mobile phase should be polar. So methanol, water, acetonitrile, ethanol, or buffers in a different proportion can be used as a mobile phase. While in case of normal phase, the stationary phase is polar, so obviously mobile phase will be non-polar. And in that condition, we can use a non-polar solvent like pentane, hexane, heptane, dichloromethane, butyl chloride, and so on. These solvents have advantage there that viscosity is low. So low pressure is required to be applied. But at the same time, it has disadvantage that they are highly flammable, toxic, and costly. So that is why care has to be taken while using a normal phase, working with a normal phase chromatography. Now you can use buffer also as a part of the mobile phase. The reason is obvious. Most of the pharmaceutical compounds are weakly acidic and basic. So if we want to control the pH of the, or if we want to control the ionization of the compound, we should control the pH of the mobile phase. And the pH of the mobile phase can be controlled by using buffers. Okay. And the factors to be considered are, we should consider the UV cutoff value for the buffer solution. And what is the buffer capacity? Okay, as already we have discussed in Henderson-Hasselbalch equation, we should adjust the pH in such a way so that compound remains in ionized or unionized form. Suppose the pKa value is 5, and if you are selecting pH 5, what will happen? Half amount of the compound will be in ionized form and half amount of the compound will be in an unionized form. And due to that, peak broadening or distortion of peak or splitting of peak will occur. Okay, so that is why always care has to be taken. Whatever the pK value of the compound is there, at least you should keep pH 2 unit above or below, depending on your requirement, where you want to separate. Fine. And normally the buffer concentration should be between 10 to 50 millimolar. You can use high concentration of buffer, but at the same time, there are chances of precipitation of buffer in a mobile phase chamber. So care should always be taken to use a low concentration of buffer while working with HPLC. Every buffer has specific buffer capacity, and in a particular pH they can work. So like potassium dihydrogen phosphate and phosphoric acid buffer has a pK value 2.1 to 7.2. Citric acid and potassium citrate buffer has 3 pK values. You can even go with a potassium acetate and acetic acid with a pK value 4.8. So again, the selection of the buffer should be based on the pH that you want to control. Okay, so based on that, you have to select the buffer which can provide you the best pH control with a good buffer capacity. Even in a mobile phase, you can add peak modifier. Now, what these peak modifiers are? These peak modifiers are reversibly or irreversibly combining with the stationary phase, and it will avoid tailing in your compound, tailing in your peak. Many times in a chromatography, we have observed that we get a tailed peak or fronted peak. The reason is that your compound gets adsorbed on the stationary phase for a longer period of time. It do not get eluted out of the column. So what to do? We have to add a compound, or we have to add a modifier or displacer which can displace this compound so that I can get a very sharp peak. So triethylamine or hexylamines are normally used for the separation of the basic compound. And for acidic compound, we can use acetic acid or sodium acetate, which helps you to improve the shape of the compound. Just a minute. Yes, so you can add peak modifiers for improving the peak shape in chromatography for acidic and basic compounds. Fine. Now, based on the compound, based on the solid molecule, you have selected mobile phase. The next thing that comes is the stationary phase. Normally, stationary phase are packed in a column, usually made up of stainless steel, and it ranges from 5 to 25 centimeter. These are straight columns which are used, and the inside diameter of this column is usually 3 to 5 millimeter. Normally 4.1 mm diameter is used with a particle size of 3 to 5 micrometer. So the stationary phase that is packed inside the column has 3 to 5 micrometer particle size and the internal diameter of 4.1 mm. Now, what characteristic of stationary phase which is important? Ideally, it is not in our hand as an analyst to select the characteristic of stationary phase because it is already been supplied by the company. And obviously, we have a limited number of columns with which we are working. So this question normally do not come into the picture, but still we should be aware about the certain characteristic of the stationary phase as an analyst. First thing is surface area. Obviously, we need a more surface area so that better separation of a compound can occur. So if a particle size is less, we will get more surface area. Second, particle shape. Which shape of particle can be used as a stationary phase? Ideally, spherical particles should be preferred. The reason is obvious. It provides more surface area. Third, pore size. If your particles are porous in nature, it will affect the separation of the compound with different diameter. Suppose if you want to compound separate, or if you want to separate a compound based on their size, the pore size of the stationary phase is very much important. Okay. Next is particle size. As already we said, if the particle size decreases, surface area increases. So ideally we want a lesser particle size for a stationary phase. But if we go on reducing the particle size, it may happen that the particle size is so small that it tightly packed inside the column and we need to apply more pressure. So ideally 3 to 5 micrometer particle size is preferred, but in case of UPLC, ultra performance liquid chromatography, the particle size goes up to 2 micrometer. Okay. But there they have taken an advantage of reducing the column length. They have just make a column length of 5 centimeter to 10 centimeter. Okay. So that advantage can be taken. And obviously the stationary phase should have uniform diameter. Fine. So that care has to be taken. More surface area, spherical shape, porous structure, and reduced particle size. That is the ideal requirement for any stationary phase that we are using. As I said, there should be a narrow particle size distribution or a uniform particle size distribution. Stability, obviously, when we are going to force mobile phase through the stationary phase. Okay, so our stationary phase must be stable to various mobile phase conditions. Fine, because we are going to use buffer, even we are going to use mild acid, weak acid as a part of mobile phase. We are keeping pH around 2 or 3. So in such condition, it is necessary to have a stable stationary phase. And even we are going to apply pressure, 3000, 4000 psi. So it must be stable and it should withstand such a high pressure. Okay. So chemical stability is also important. Another important parameter is surface reactivity. Ideally, we need surface groups to which a compound can interact. But too much reactive groups will cause irreversible reaction with the sample molecule. Your sample molecule will irreversibly react with your surface compound. And in such condition, it may create a problem. How to dissolve this sample molecule? Okay, so surface reactivity should be minimum. It is required, but depending on the type of the compound that you are separating, it must be there. And even if it is required, you can carry out the end capping also. Normally, two types of column packings are used. One is pellicular and second is porous. Okay. And what kind of stationary phases material that can be used in chromatography? It depends basically on the separation principle. Like in adsorption chromatography, we can go with a silica gel. 99% of the columns are made up of silica gel only. Even alumina can also be used, but alumina has a disadvantage that the surface area is very low. So the separation will be poor. So that care has to be taken. Another one is partition chromatography. In partition chromatography, the stationary phase should be non-polar. So normally C18 or C8 column or phenyl columns are used. If your separation principle is ion exchange chromatography, then you may have a cation exchange resin or anion exchange resin. Size exclusion chromatography, where you are going to separate your compound based on sizes. So where a dextran cross-linked polymer is used, which is highly porous structure, which contains inside pore, and based on the size, the compound will get separated in it. You may have affinity chromatography, where either antigen or antibody is bonded on the stationary phase, and the separation will be carried out for the particular antibody. So, based on the separation principle that you have selected, you can go with the specific stationary phase. Now, mobile phase has been selected, stationary phase has been optimized. Next thing that comes is which detector we should use. Obviously, if your compound is having a chromophoric group, you should go with a UV visible detector or photodiode array detector. If your compound is fluorescing or fluorescence compound, then you can go with a fluorescent detector. If nothing is there, you can go with a universal detector like refractive index detector or electrochemical detector. And if you want more specific analysis and if you want to identify the compound, you should go with a mass analysis. So LC, that is a liquid chromatography, or HPLC, can be coupled with a mass as a detector. Okay. So depending on the type of the work that you are performing, you should select a detector. But there are other factors also which will affect the selection of the detector. Availability. In your lab, which detector is available? Obviously, we need to decide the choice of detector based on these. Second thing, properties of a compound. What is the property of my compound? Whether the compound has a chromophoric group or not. Whether I need a Buch purity analysis. If I need a peak purity analysis, I should go with a photodiode array detector. Do I need sensitivity? Yes, in that condition, I should go with a mass detector or UV visible detector. Which mobile phase I am using, whether the mobile phase is interfering with the detectors or not. Okay, so these criteria will decide which detectors has to be selected. So if we go with the HPLC method development, if you want to start, first thing is we need to study the properties of the molecule that we are going to separate. Then we will select the stationary phase. Obviously, this is not in our hand because we have limited number of columns with which we have to work. The important thing is we need to select the mobile phase and the detector. Okay. So if we start with the reverse phase chromatography, we normally start with a strong solvent like methanol water 90-10. And slowly, depending on the type of the response, we will go on reducing the content of the methanol. Okay. Depending on the type of the separation achieved, we can go on reducing the content of the methanol or even change the methanol with the acetonitrile also. If there is a tailing in the peak, we can use a buffer so that the ionization of the compound can be controlled. When we start with a buffer, we should start with the low molarity of the buffer, considering its pK value. And even then, if you find tailing or fronting in the peak, you can go with a peak modifier, depending on the type of the compound that you are separating, whether a basic modifier or acidic modifier that is required. Certain care that we need to take while we are working with HPLC. We need to wash the column. If we are not using any buffer in the mobile phase, then once your analysis is completed, HPLC instrument should be run for at least 30 minutes using methanol water or acetonitrile as a washing part. And if you are using a buffer, then first run warm water, warm HPLC water for 30 minutes, and then use methanol water or acetonitrile water for further washing. Because it is necessary to remove traces of buffer out of the column. Otherwise, this buffer will get precipitated inside the column and it will raise the pressure for the next analysis. These are some of the troubleshooting. I think that is not required much, but I'll go briefly. If there is a peak tailing, due to that, there will be reduced resolution, there will be compromised precision and less reproducibility. What may be the reason why you are getting a tailed peak? It may be due to bad column or improper selection of the mobile phase or pH. Or it may also happen that your column is not end cap, or there is an overloading of sample. Okay, maximum sample has been applied, which is beyond the capacity of the stationary phase. So in that condition, the chances of peak broadening or tailing will be there. Now, the another problem that you may encounter is retention time of your peak changes every time. It means that you are not getting reproducible result. The reason may be your mobile phase composition has changed. Your column or detector temperature is not maintained constantly, or the length of the column tubing is not proper. Okay, or it may happen that your stationary phase has been damaged. Many a times we are using acidic or basic mobile phase. pH is very low. In such condition, it may distort our stationary phase packing. Okay, so the care has to be taken. How to solve this problem? Obviously, if there is a problem related with the mobile phase composition, we should prepare a mobile phase of appropriate composition only, and we should equilibrate the system with the mobile phase for a longer period of time. Okay. We need to sonicate the mobile phase to remove the air bubble, because air entrapment also causes a problem. Air entrapment will lead to pressure fluctuation. So that is why it is necessary to sonicate the mobile phase to remove the air bubble. And as I said, we need to wash the column every time after use. Prepare the mobile phase accurately so that the composition do not change. Fine. Now, many times you may observe peak splitting and shouldered peak, like there is a hump in a peak. What may be the reason? Again, there will be column overloading, or two compounds are getting eluted at the same time. So it may give you distorted peak or shouldered peak. Okay. Column packing is damaged, column is contaminated. So these are the reasons why which you may observe peak splitting. Fine. Now how to solve this problem? So pH should be at least 2 units apart from the pKa value of the compound. That has already been discussed in a Henderson-Hasselbalch equation. And if your frit is contaminated, we need to replace the frit. If possible, we should carry out the column regeneration. Yes, many times you may observe a broad peak, maybe due to column overloading or the mobile phase strength is weak. There may be pressure fluctuation. The reason is air is entrapped, or if there is a problem with your gradient dilution system of HPLC. So how to solve this problem? We need to degas the mobile phase at least 5 to 10 minutes before we use the mobile phase. If your column is damaged, okay, what may be the reason why your column gets damaged? If you are using a buffer where you have not washed the column after use. Second thing, if you are using a very low pH or very high pH of the mobile phase, which causes stationary phase degeneration. Fine. So the care should be taken. We should use HPLC column between pH 3 to 8 only. The mobile phase pH should not go beyond that. Okay. And always have a habit of washing the column once the analysis is over. Yes, many times you may observe this problem also. Your baseline is not stabilized. You may get a spurious peak or high noise level. So what may be the reason for that? Your mobile phase may be contaminated, or air is entrapped, or there is a microbial growth. Every time prepare a new or fresh mobile phase for the analysis. Don't use the old one. Because if water content is high, in that condition, there are chances of microbial growth. So care has to be taken to use a fresh mobile phase. Fine. I think I have discussed this part. Yes. So there are certain precautions that we need to observe while operating HPLC system. Always check the cutoff value of the mobile phase before selecting analytical value or before selecting a particular mobile phase for the analysis. Wash your column properly once your analysis is complete so that your column maintains its adsorption property or separation ability after the analysis is over. And wash the injector port with HPLC water and HPLC methanol after analysis. See, many times we forget to wash our injector port. Okay, so what will happen? The traces of previous sample will remain inside the injection port, and when you perform the next analysis on the next day or after a few days, you may observe some ghost peak. Second, equilibrate column with the mobile phase before you start analysis. Definitely, we want to perform analysis in the least time, but not at the expense of your result. So at least equilibrate your column for 20 to 30 minutes with the mobile phase. Allow it to stabilize, allow the pressure to stabilize, and then start the analysis. Okay, and perform dilution of the sample in the mobile phase. If your compound is soluble in mobile phase, then always try to perform dilution with the mobile phase. Otherwise, it will give you a large void peak. So these are some of the points that we need to consider while developing HPLC method and while operating this HPLC system. Thank you. Thank you. Yes. Any questions from your side?
Hello. Any question from participant? I think Lima madam, as we are running short of time also, we'll collect the question from the students and with sir's permission, we can convey that questions to sir through mail and get the answers.
Definitely, madam, definitely.
Right, sir. So, sir, thank you very much for enlightening the audience and giving very, very important information, which will definitely help them in their future projects, specifically in LC method development, whether it is HPLC or HPDLC.
Thank
So
you. Thank you so much, madam.
on behalf of Parallel Institute of Pharmacy, Parallel University, I heartily thank you, sir, and hope that in future also we'll get the guidance from your side and information, knowledgeable information from your side.
Thank you. Thank you so much, madam, for giving me this opportunity to share my views. And I hope the purpose has been solved. Thank you.
Yeah, with that, I would like to thank Dean Faculty of Pharmacy, Parallel University, Dr. Abhay Dharamse, who is continuously encouraging us and giving continuous support for arranging quality expert talks. I thank a management of Parallel University for providing us platform for conducting such webinar events. And I thank PU webinar team also for their support in organizing this webinar. And last but not the least, without whom this webinar is not at all successful, I would like to thank all the audience, including teachers, students, and all other researchers that making this webinar very successful. So once again, I thank all who has directly or indirectly supported to make this webinar successful. Thank you very much, sir, once again. Lima madam, over to you.
Yeah, we can conclude the session now. Thank you so much, sir.